Welcome. So I've got a number of emails about having some issues in trying to figure out how to draw these graphs in terms of like doing a response to a shock of whatever the source is that's in the homework. There's multiple sources. So I thought I would go over, we'll do two different examples. One that's going to be supply side, one that's going to be demand side. Now, of course, this isn't going to be giving you all of the answers. It really won't be giving you very many answers at all on how to explicitly answer this stuff. However, it will give you some insight as to what the internal mechanisms are that are operating that'll help you out with this stuff. So, this is the setup that you have in your homework so far. I left everything blank, and the idea is that you are going to have to first draw out the initial equilibrium. So, I'll say step one, draw the initial equilibrium. Okay, so we'll start out with just some kind of a production function. So we've got y equals a times k to the alpha times L to the 1 minus alpha. This is the standard Cobb-Douglas production function that we've seen in the past. Nothing is different here. Now, we've got output done in terms of labor. So what we're doing is we're holding the capital stock fixed. I'm going to draw a bar over K so that you know it's fixed. That's not necessarily a requirement in the homework. You don't have to do that if you don't want to, because I'm going to know what you mean. I'm going to know what's going on here. So, now, we've got this. So this is the firm deciding how much to produce. Now, when they do decide how much to produce, when they do their optimization, they're going to get a labor demand, like this, so we'll call it LTD. And we're also going to get a labor supply. We're going to call it LTS. Now, from here, the equilibrium in the labor markets is going to determine what the equilibrium wage rate is, or real wage rate, so we'll call it WT star. It's real because it's lowercase. This is going to be the optimal amount of labor that's used to produce this optimal level of production. It's LT star, YT star. So at this point here, we draw a dotted line over this YT equals YT. It converts this horizontal dotted line into a vertical dotted line. We draw it up until we hit this graph here, and this is a vertical line. We're going to call it AS for aggregate supply. All right, now the last thing that we need to do is just draw in an aggregate demand curve. So aggregate demand is just going to be a downward sloping curve. Now where these two guys intersect, we're going to have an equilibrium price level. Call it P star, like this. And this is going to be the initial equilibrium. Now, step two, suppose there's a massive influx of workers. Call it immigration shock. Put this in this line here. All right, so we'll say, I don't know, the wall never gets built or something, right? So we get more workers coming in, more people come into this country wanting to work, And so if there are more households that want to work, they're willing to supply more hours at the aggregate. So more workers means more labor supply. So with an increase in labor supply, you get this. On LTS1. So it's going to trigger a positive labor supply shock. Okay, so there's a new labor supply curve here. There's been a labor supply shock that gets triggered. Now when that happens, well, now what we need to do is we need to figure out, okay, what is in equilibrium, what is not in equilibrium? Well, currently labor markets are not in equilibrium. We can see they're not in equilibrium. This is where we are here, right? But if there's a labor supply shock, the equilibrium is going to change. This is the new equilibrium. There's a new labor market equilibrium. Wages fall and labor goes up. Right? Remember, any supply shock that you see in that particular market, there's going to be an increase in the quantity and a reduction in price. Or, conversely, there's going to be a reduction in quantity with an increase in price. Right? Well, the quantity of labor hours worked, the price of labor is the real wage rate. So wages will reduce while the labor hours supplied will increase. So we have a reduction in the real wage rate followed by an increase in labor. So what we're going to do is we're going to draw this dotted line all the way down over here where we see there's an increase in labor. Now along this dotted line, somewhere in this graph, it's going to be crossing with where the production curve is, which is right here, this little black dot here. So this little black dot, this is the new level of, or the new amount of production that's being made. So output increases. So output increases from Y star to Y prime. Note, under a labor supply shock, there is no change to technology. Because technology is going to determine whether this thing shifts up or down. Right? Because we've got Y is a function of L. So if L were to change through a labor supply shock, this graph is defined in terms of L. So there's no shift in the production curve. The production function doesn't move. Right? Note how Y and L are not A. So if A were to move, if there was a technology shock, this would shift either up or down. So if something new gets invented, for example, if there is some new technology that gets invented that makes production more efficient, if there is an ailing population, and this population is quite ill, because they're ailing, ill, if they're sick, and then there's this new medicine, this new medication, this new treatment that comes out, well, the population's not as sick anymore. But that new medication means that things can be produced more efficiently now. So if there's a new medication that's made, there will be a technology shock, and there will not be a labor supply shock. Hint, hint, hint. Sorry if that looked a little like mean and like, I really didn't mean for it to, I promise. And I just don't want to start this video over or try to re-edit it because I actually don't have any film editing software. In case you haven't noticed, I am just using my cell phone that is taped to a tripod in order to record this. So, yeah, video editing skills. Enough said. Okay, so output moves. Output increases from y star to y prime. And we trace this new dotted line over to the y equals y line, which is over here, and we trace a dotted line up until we get here. Booyah. There's an aggregate supply shift, meaning the price level is reduced from P star to P prime. Consistent notation. Like this. And this would be all that you would have to show for a positive labor supply shock. So I'll do step 6 just to summarize. In this case, the causal ordering of shocks would be that there's first a labor supply shock, so labor goes up. Now, under the labor supply shock, if labor goes up, the real wage rate falls, output increases, meaning price falls, like that. So this, in this 4-graph system, would be how we would identify a positive labor supply shock. Now, the nice thing about this is, I just realized you couldn't see me there, the nice thing about this is all linear. So because this is all linear, I don't know why I have this in parentheses. Erase your parentheses if you made them. Because it's all linear, we can just flip all the signs. So if we wanted a negative labor supply shock, right? Let's say there's a mass exodus out of the country or out of the world. If you've seen Men in Black, when the, Tarkalians? No, those are from Star Trek. Who are the guys of the galaxy? I don't even know why I'm asking you this because I can't get a response from you in real time. Whatever the aliens are, they're not Rigelians either because those are also from Star Trek. We'll call them Tarkalians, even though we know they're not Tarkalians. We'll assume that they are. So the little human suit with like the tiny little alien guy that's like in his chest, and he's like, the galaxy is on Orion's belt. And then he like dies. Whatever those things are called. When they threaten to blow Earth up for not handing over the galaxy, right? Remember, all the aliens left the planet. So they're like, dude, screw this. They're about to blow Earth up. I don't like that idea. So they all left because Earth was about to be blown up. So because they all left, there would be a negative labor supply shock, right? Well, this is all linear here. So what happens is if there's a negative labor supply shock, the signs that we would see would literally just be the opposite of this. Labor supply would reduce. So there's a LT with a down arrow. Because that happens, the wage rate's going to increase because they're going to need more workers, but there aren't more workers. So what they're going to do is they're going to offer a higher wage to the remaining workers who are going to work more hours. So wages will increase, output will fall, and the price level will increase. notice this goes up, this goes down. This goes down, this goes up. This goes up, this goes down. This goes down, this goes up. You just flip all the signs. It's like just multiplying everything by -1. And because we have a linear system of equations here, we can do that. I know this technically doesn't look linear, it's linear in parameters. I'm not going to get into what all that means. Don't worry about it. Just this is all linearized. I just realized I am drinking in front of you guys. Again, I don't want to make a new video. So what I am drinking is actually tea. This isn't Buffalo Trace bourbon. This is just tea. I just put it in this bottle of bourbon because people are hoarding and I can't get new glasses. So this would be what a positive labor supply shock looks like. Now, hang tight. I will pause this video. I'm going to erase everything and start over, and I will show you, you know what, let's do 2 shocks. 2 more shocks. I'll show you 2 more shocks, and then we can sort of figure stuff out from there. So, hang tight. I'll be right back. Okay, so I'm back. Yay! Now, I don't want to give you all the answers, like I said. Now, I've given you some hints on some things in terms of how to sort of interpret this crap. So what I'm going to do now is show the effects of a negative technology shock, because that is not in the homework. Hint, hint. I hope that one looked a little bit nicer than the one I did before. Fingers crossed. So let's say there's a negative technology shock. Now, if there's a negative technology shock, what happens is, because the negative technology shock is going to occur on the supply side of things, so it's going to occur in either this graph or this graph. This tea is utterly delicious. I just got done watching some Star Trek The Next Generation to get my mind off of how terrible Star Trek Picard was. If you're a Star Trek fan, do not watch Star Trek Picard. It is freaking terrible. So we'll pretend that that's not pretend. Oops, fix that in post, except there is no post. It's Earl Grey tea. It's Earl Grey, and it's delicious. It's intoxicatingly delicious. I love it. So, let's say there's a negative technology shock. Now, a negative technology shock in the economy is ultimately going to put us into a recession, just like a negative labor supply shock will put us into a recession. So, according to the RBC model, it's either a negative technology shock or a negative labor supply shock that will put us into a recession, at least in terms of the variables we're looking at. It'll put us into a recession. Therefore, it's going to be an inward shift of the aggregate supply curve. So, we need something that's going to be shifting aggregate supply inward. So what's that going to do? Well, like I said, it's either going to be a labor supply shock or something going on with production. But because I said technology, right, there's some sort of a technology shift. Remember, A is capital A accounts for technology. That burp was brought to you by Mountain Dew. Thanks, Pepsi. So, there's a negative technology shock, which means this AT term is what's going to be causing some shifts here. Now, this negative technology shock, so I'll do my steps. AT shifts down, meaning it is less than 1. Because remember, at a steady state, it's equal to 1. So it's going to be less than 1. Therefore, it's going to shift this production curve inward. And you have a red marker. Thanks for the red marker, Mom. This red marker brought to you by my mom. Thanks, Mom. So many shameless plugs. So it's going to shift down. So production shifts downward like this. Now, when production shifts down, remember, it's going to pivot downward. Because when I explained what the Inada conditions were, remember, basically what they said was, part of what they said, was that this production curve always started at 0. 0 inputs, 0 output. So it always starts at 0. So what it really does is it pivots downward, giving us this yt, we'll call it prime, equals at prime kt to the alpha, lt to the 1 minus alpha. Now k and l do not change in this production function. Why? Because this is a technology shock. The availability of the inputs remains the same. Just the use of the inputs is going to fall. Right? Now, whenever this happens, if this ever shifts downward, the amount of labor we're going to use is going to be on the left side of the original dotted line. So let's just put it here, like that. Okay? So, we're going to assume that less labor is needed, because why would you need more labor to produce less? We're going to have a dotted line we're going to draw upward. Until we get to this point here on the labor supply curve. Now we draw to the labor supply curve because labor supply is not shifting, labor demand is shifting. Any demand for labor is going to be determined by the firm. Any supply of labor is going to be determined by the household. So we draw a dotted line over until we reach our aggregate supply, aggregate demand framework, the top right graph. And we draw a dotted line over to get P prime. You can see prices increased. And then just to put this over here, although it's not required to do it on this graph, I will draw a dotted line down just to show output falls. So in the event of a negative technology shock, this is what you would have. All right, so there's a negative technology shock. Technology decreases, causing a downward shift in production. Let's say production shifts down. Now, 2, firms need less labor so labor demand shifts in, so labor drops. Now labor supply stays constant. If labor supply stays constant, LTS doesn't shift. So if there's a downward labor demand shift, real wages are going to fall. They're going to fall from W star to W prime, which is what we have here. Wages fell. And we trace that dotted line over and then up. There's an inward shift the aggregate supply curve from AS star to AS prime. Meaning prices fall from P star to P prime. Now, if we want to summarize this in terms of the qualitative changes, output falls because this originates in the output function, right? Which means labor hours fall, wages fall, prices fall. Sorry, prices don't fall, they increase. Derp. For those of you that caught that before I did, congratulations. For those of you that didn't, congratulations, I caught it, it's fixed, we're better. Prices increase. So to summarize, output shifts down. Firm needs less labor because they need less labor, but the labor supply stays constant. Wages are going to have to fall, causing an inward shift of the aggregate supply curve, so prices are going to increase. Notice here, both of the shocks I've showed you so far have been supply-side shocks. These shocks will imply that output and price will always move in opposite directions. Now, if this were to be a positive technology shock rather than negative technology shock, we just flip the signs again. So output increases, hours worked increase, real wages increase, price level falls. All right, the price level in the negative technology shock is falling because there's less production. If there's less production, there's less supply, meaning aggregate supply shifts inward, holding demand constant. If there's less stuff but demand is the same, the price level is going to have to increase. So that's why we're going to see an increase in the price level if there's a negative technology shock. This is putting us into a recession. Now here's a problem with this particular model. I was going to talk about this when we got to the new Keynesian model, but what the hell, it seems like a good time to talk about it now. Notice labor markets are in equilibrium. Regardless of what the shock is, regardless of what happens, labor markets are always in equilibrium. Now that's strange, that's weird, because what this says is there is no involuntary unemployment even if we're in a recession, which is never going to be the case. If we're in a recession, there's involuntary unemployment. People get let go from their jobs, even if they don't want to be let go from their jobs. But what this model says is the wage rate drops, and remember when I showed you the reserve wage rate? What this is saying is the wage rate's dipping below the reserve wage for certain households, therefore they opt to not work anymore. So we have voluntary unemployment when there's an inward supply shift, prices increase. Okay, now this change here, the reduction in output and the increase in price, that all makes sense, right? The reduction in labor demanded and even the reduction in wages makes sense. But some of the underlying stuff behind it doesn't make sense. Because what we're seeing is, according to this model, with this vertical aggregate supply curve, perfectly flexible prices, totally perfect competition in the markets, etc., there is absolutely nothing that's inefficient about this equilibrium, even though there's unemployment. That doesn't make a lot of sense. When was the last time there was a recession and people go, oh, you know what? We're in a recession. I'm seeing average wages fall. You know what? I don't think I want to work anymore. I'm just going to drop out of the labor force for a while. That doesn't happen. So that's a problem with this model, that the next model kind of fixes a little bit. Now, it's one of those weird little nuances of the model that you may not get at first glance. I didn't get it at first glance until I read some issues with the model, and then I was like, oh my God. So this is what a negative technology shock looks like. If there were a positive technology shock, this curve would shift up, this guy would shift over here, this guy shifts over here. And you get these signs instead. Cool. So this is a negative technology shock, and we will do one more shock, and then we will be good. At least you should be good. I'll be fine, but this is more to help you. This isn't to help me. So, one moment. Uno momento, por favor. Which I think is like French for I need a minute, please. Okay, welcome back to the third and final shock. So, now what we're going to be looking at, we're going to look at a positive labor supply shock when labor demand is perfectly elastic, meaning it is straight line. Right now, it's not just, well, actually they're all straight lines. It's a perfectly horizontal line when it's perfectly elastic. So if something is relatively elastic, it's a pretty shallow line. Weird shit. Give me a second. Oops.